just as we've done with the sine and the cosine graph and use the unit circle, we can also use the unit circle to get an idea of what's happening with the tan. So if we just draw a unit circle, and don't forget it has a radius of 1, that's why we call it the unit circle. Theta, we've got point P out here, and that is my y coordinate, and that is my x, so x, y, so that'll be x, right angle triangle, that's got a length of x, that's got a length of y. And we know from work we've done with the unit circle that the tan of theta is equal to y over x. Now if this is the origin, y over x is the gradient of OP. So that the gradient of that line is simply the rise over the run, which is the y over the x. Now if we went round the circle in radians, so that is 0 radians, this is pi on 2 radians, this is pi radians, and this is 3 pi on 2 radians. The coordinates of this point here, if it's a unit circle, will be 1, 0, and this will be 0, 1, this will be negative 1, 0, and 3 pi on 2 will be equal to 0, negative 1. Now to get an idea of what the tan graph looks like, so we've got y and x, and y is equal to tan of x. Okay, we know that the tan, so when P is at this point here, the tan of 0 is equal to, it's the y coordinate divided by the x, so it'll be 0 over 1, which will be equal to 0. So the tan of 0 is 0. So there is a point on my graph. Maybe we'll just do that in blue. Okay, so tan of 0 is 0. So as point P moves from here up to there, you can see that the slope starts off very gentle and gets steeper and steeper and steeper. And what happens at pi on 2? So if we go back and go tan of pi on 2 is my y, which is 1 over my x, which is undefined. So divisibility by 0 is undefined, so there is no y value here at pi on 2. So if you like, at pi on 2, I know that the graph is not going to cut when x is equal to pi on 2. So my graph, as I said, it is the slope of OP, and you can see that it is getting steeper and steeper. So we can say that it goes a little bit like that. Now, if we start at the origin and go in this direction, we're going in the negative angle. So 3 pi on 2 going all the way around here is the same as going negative pi on 2. So from going there to there is like going negative pi on 2. It's exactly the same as going all the way around there. We get the same angle. So the tan of negative pi on 2, once again, it's still the y coordinate, negative 1 on 0. And that's also undefined. So negative pi on 2 will be out here. And I know the graph is not going to cut there either. What's happening to the slope of OP? Well, it is a small negative there, and it is getting steeper as a negative. So here the graph is negative, all my values are negative down here for the y value, and so the graph is going to look a bit like that. Alright, so once again, as we talked about before, this is what's called one period. That's a section of the graph that looks like it's just going to repeat itself. What happens over here? We know it's undefined at pi on 2. Let's have a look at pi. So we got the tan of pi is equal to the y coordinate 0 over -1, which will be equal to 0. So at pi, so that's pi on 2, pi, we know that tan of pi is equal to 0, so that's going to be a point on the graph. Pi on 2, what happens just on this side? So if we just go on our graph here, what's the gradient look like here? Well, it's quite a large negative value, so it's going to be down here, and the graph is going to actually go up and through, so it'll virtually be a repetition. Actually, we can do a bit better than that if we want to make it look exactly the same. So it goes up and so on, and if so that will be from pi on 2 pi, so the next one over here will be 3 pi on 2, so the next dotted line will be 3 pi on 2 out there. So they have a period of pi from minus pi on 2 to pi on 2 is 1 pi. So if we went 1 pi back there, we'd get to -3 pi on 2, and we'd get another period in there as well. So the tangent graph looks like that, with lots of places where it is undefined.